Hello, this is Mr. Wilford, and I just want to go through week 2 with you here. In week 2, we're going to be covering the next 3 sections of chapter 1. So we're going to be doing sections 4, 5, and 6, and then again we'll take a quiz at the end of the week. Make sure again that you are looking over the material here in the online textbook. A lot of good material here again, a lot of good examples and quizzes, practice quizzes and things like that. And then also make sure again that you are taking a look at the and doing the homework for the week as well. For each section, again, there's online assignments, there are book assignments, there's a discussion assignment, um, and then the quiz. And then also make sure again throughout the course that you're looking for any special assignments that are thrown in there as well. Also, besides this little intro video here, there are some examples that you can look at as well. Sometimes they are odd problems. Maybe some of the problems are worked out for you, so you can take a look and kind of check your answers from the book as well. Of course, anytime you have questions, please let me know. All right, let's get started here with talking about the 3 sections for this week. In section 4, we're talking about simplifying algebraic expressions. Now, this is where it really starts to get interesting, and a lot of the algebraic concepts are here. When we talk about algebraic expressions, what we're talking about are basically numbers and letters put together with plus and minus signs. We're not really talking about an equal sign. We're not trying to solve for a variable. We're actually just trying to simplify and combine different terms. And so this is an example here of an algebraic expression. Every time you have a plus or a minus sign, now these are both plus signs, but every time you have a plus or a minus sign separating numbers and letters, those are called terms. So in this example, we have actually 3 terms. Okay, now to have like terms, you have to have the same letters, and those letters have to have the same exponent. Okay, so these are not like terms here, so we really can't add those or combine those terms at all. In the beginning here, what they're going to actually have you do is do a couple of examples where you're reading a problem and you're just trying to take the words and put it into an algebraic expression. So when you look at these first few examples, that's kind of what they're going over there. You've probably heard, or maybe you haven't, but there's this PEMDAS, it's called, and it basically has to do with the order of operations. When you're simplifying algebraic expressions, you want to keep this order of operations in mind. We have parentheses. We look at those first. We have exponents. We look at those next. Multiply and divide from left to right, then finally add and subtract left to right. Now keep in mind, we're combining like terms. Okay, so what's going to happen here is in the beginning, in the first few examples here, as you go through and you're looking at algebraic expressions, they're actually going to give you numbers to plug in for the variables, for the letters. So it's helpful to actually write this stuff out, and then so I'm going to plug 4 in for the x's in red here, you can see, and then 7 in for the y's, and then you simplify this. Now, if you have a good calculator, your calculator will actually do most of the work for you. As long as you punch it in correctly, your calculator isn't going to mess up, and your calculator will follow the order of operations. Okay, so for these first kind of problems here of simplifying expressions, you're actually plugging in numbers, and so all of these are numbers, and they're going to be able to be combined and simplified to one final answer. When you get down here, this is where we start talking about like terms. And remember, like terms have the same letters, but they also have to go to the same power or exponent. So as you're going through and looking at some of these problems, make sure that you're finding the like terms. Sometimes people will put a little line underneath the like terms, so they might, in the online text they can use color here, but maybe when you're writing out the problems, maybe you put one line under 7x squared and a line under x squared. Remember, there's a 1 out here, so 1 plus 7 gives me the 8x squared. Also remember the properties that we've talked about in the past. Here they use the distributive property, so they take this b and they distribute that to each term, and now all of a sudden you can see we have some like terms, and they add and subtract those like terms. Okay. And then we have just kind of a real world problem there, and then again we're looking at these problems here. Make sure again that you look in the week for the book homework, and you're going to be doing some of these problems there. If you have questions, make sure again you look at some of the examples that are given, and let me know if you have other questions beyond that. Really simplifying algebraic expressions, especially these problems right here, are so important because you want to make sure that you get this stuff down. You want to make sure that you understand how to do the basic algebraic stuff, because that's going to help as we get further in the course. Okay, so that's section 4. Let me go to section 5 and talk briefly about that. In section 5, we're talking about properties of exponents. Now, exponents are like powers. Okay, if you have a number or a variable to an exponent, you're taking that to a power. You're taking that and you're multiplying it that many times. All right, now you have to be careful. You can see in this example here that you have to be careful with exponents, because how you write them can change your answer quite a bit. Okay, like here, x cubed is right here, so just the x's are x times x times x. Here now all of a sudden we have parentheses, so now I have 2x cubed, but the negative sign is sitting out in front. There's only one of those. Here I'm taking the whole expression here and writing that out 3 times. So when you're simplifying these, you have to be very careful and take note where the parentheses are and where the powers are. So what am I actually taking to the power, or to the exponent? This 4y to the power of 3, the parentheses, I'm going to take that 3 times. Negative a squared, I don't have any parentheses, so I'm just taking the a times a. Okay, so we're writing it out like that. Be very careful again. Now, there are some properties of exponents. There's a zero exponent property. Anytime you have a number to the power of 0, it's going to equal 1, unless it's 0. That's why they say non-zero. So any other number besides 0 raised to the 0 power is going to equal 1. You can even try that on your calculator. We have negative exponent property. Anytime you have a negative exponent, if you take the reciprocal or you flip the fraction, it's going to change it to a positive. So here I have 3/2 to the negative 4. If I flip that fraction around, that changes it to a positive exponent. There will be some problems that you're going to do involving those properties. Here are some additional properties of exponents. Okay, make sure you take a look at these. Product of powers property. Okay, and you can kind of see here using the numbers, the examples, it's a little bit easier sometimes to understand what they're talking about. Quotient. Okay, if you have a power, you're going to subtract. Here you're adding the exponents. Here if you have a fraction, you're going to subtract the exponents. Here if you have a power of a power, if you have an exponent on top of an exponent, you're going to multiply those exponents. Here, power of a product property. This is just saying that if you have 2 numbers multiplied, that exponent actually is going to go to each of the bases. Okay. Here, same kind of thing, power of a quotient property. This, if you have a fraction, a over b, that power is going to go to the top and to the bottom. Okay, so these properties are important to take a look at and understand and practice with. And so we have some examples here where you're using some of those properties. Take your time. Write things out step by step by step so that you can see exactly where you're going and what you're doing. Okay, if you have questions with that, make sure you let me know. One other thing they talk about in this section is something called scientific notation. Maybe you're familiar with that from a science class. And basically here what you're doing is you're moving the decimal point. Okay, if you have a positive exponent, I should say you're always taking a number between 1 and 10, scientific notation, times 10 to a power. It's always times 10. Here, if you have a positive exponent, you're going to move the decimal place to the right 7 places. This is a big number. If you have a negative exponent, you're going to move the decimal point to the left, and you have a very small number. Sometimes your calculator, if you have a good calculator, you can actually do scientific notation with your calculator. It makes it pretty easy. So check into that. Let me know if you have a question with that. Again, we have a real world problem here, which is always good to take a look at. And then we have our problems here again. And that's pretty much section 5. Let me go to section 6. Now, quickly, I'll talk about section 6. This is relations and functions. And relations and functions are kind of almost the same thing. There are some differences. There's something called the relation, which is basically any kind of equation at all that you can have. Any kind of relation between an x variable and a y variable. So we call the x group the domain, the y group is the range. So the domain would be the set of x values. That's what we plug in to our equation. The range is what we get out. Those are typically your y values. So you can see that right here. Part of this is just identifying the domain and range. Domain is typically going to be your top row here. Your range will be the bottom row, and they're just listing those things out. You can plot those points. Again, x is your domain, y is your range. Here again, another example there. Now, a function is a particular kind of relation. Okay, it's very important that you understand it's like a subset of a relation is a function. Okay, there are specific rules where in a function there is only one output for each input. Okay, so each element of the domain is mapped or goes to exactly one element in the range. All right, so right here is a good example. Every one of these is going to just one number or element over here in the range. In this example, so this would be a function. Over here in this example, I have a number 2, and that's going to 3 different things in the range. This is not a function. Okay, and so you can take a look at some of these examples here and how they figure out what is a function and what is not a function. I always find it easiest to use what's called the vertical line test to determine whether something, a relation, is a function or not. If you can imagine, if you have a graph, if you can imagine drawing a bunch of vertical lines up and down, vertical lines, if each of those vertical lines hits the graph only once, then it is a function. You can see here, I'm hitting the graph right there once, and that's it. Here once. So each vertical line separately is hitting the graph only once. It's a function. Over here, if I hit that graph twice or more than once, it is not a function. So you can see here in the examples, it's real easy to use a vertical line test if you understand how that works. Okay, then again, now you have some problems here that you're looking at and doing. Again, be sure to use some of this information here on the right-hand side. Very good stuff. Interactive practice quiz is always fun to take and check your knowledge, see how you're doing. Again, if you have any questions at all, though, please let me know, and have a great week.